class again. Myself Partha Tantuboy from Sri Jharkhand Class 2 High School Tara, Jammu. Previously I am already take 3 lecture of this chapter. Now today is the last lecture for this chapter. तो जैसे कि प्रीवियस क्लास में हम आप लोगों को हाइब्रिडाइजेशन के बारे में बता रहे थे। तो हाइब्रिडाइजेशन क्या है, हाइब्रिडाइजेशन कैसे होता है, तो अगले क्लास जिस जगह में हम लोग छोड़े थे वही अभी भी बोर्ड पर हम एक बार बना लिए हैं। तो आप लोग देख सकते हैं कि इसमें हम लोग नंबर ऑफ एटॉमिक ऑर्बिटल्स के हिसाब से हाइब्रिडाइजेशन क्या क्या है वो बताए थे। उसके बाद फॉर दैट पर्टिकुलर हाइब्रिडाइजेशन व्हाट आर द एटॉमिक ऑर्बिटल्स इन्वॉल्व ये भी लिखे थे। और उसके साथ साथ व्हाट विल बी द स्पेशियल अरेंजमेंट, दैट मीन्स ज्योमेट्री ऑफ दिस हाइब्रिड ऑर्बिटल इन स्पेस। क्योंकि हम बोले थे कि द हाइब्रिड ऑर्बिटल arrange themselves in space in such a way so that bond pair repulsion becomes minimum. So to minimize the bond pair repulsion for a particular hybridization, what will be the geometry that will be given here? जैसे कि for sp3d2 or d2sp3 hybridization, the geometry will be octahedral. For sp3d hybridization, the geometry will be pentagonal bipyramidal. Clear? तो आज हम लोग इस चैप्टर को आगे बढ़ाते हुए देखते हैं कि हाउ कैन वी डिटरमाइन द हाइब्रिडाइजेशन ऑफ ए पर्टिकुलर कोवैलेंट मॉलिक्यूल। तो अब हम लोग देखते हैं कि हाउ कैन वी डिटरमाइन द हाइब्रिडाइजेशन ऑफ ए पर्टिकुलर मॉलिक्यूल। चलिए इससे पहले बोर्ड साफ कर लेते हैं। अब हम लोग हाइब्रिडाइजेशन कैसे बनती है वो देखने वाले हैं कि हाउ हाइब्रिडाइजेशन सर फॉर्म। तो पहले लेट अस टेक द एग्जांपल ऑफ sp3 हाइब्रिडाइजेशन। sp3 जिसमें 1 s ऑर्बिटल combined with 3 p ऑर्बिटल एंड द कंपाउंड having sp3 hybridization is CH4, that is methane। तो अब हम लोग देखते हैं कि मीथेन में जो सेंट्रल एटम कार्बन की हाइब्रिडाइजेशन स्टेट sp3 है वो व्हाट दिस sp3 हाइब्रिडाइजेशन occur in case of carbon in the compound CH4। So here central atom equal to carbon, valence electrons equal to 6, that is 1:2, 2:2, 2p4. But we know that during the covalent bonding or any other bonding, only the valence electron takes part. So 1 is being a inner shell orbital, it does not involve in the hybridization. Only the orbital involved or take part in the hybridization is 2s or 2p. Sorry, it is 2p2, not 2p4. Only the hybridization involved in bond formation is 2s and 2p. That is the electron distribution in 2s orbital, and this is electron distribution in 2p orbital, and that is the electron distribution for carbon central atom in ground state. So from this diagram you can see that in that situation carbon have only ability to form 2 covalent bond with hydrogen atom, but actually in CH4 there is total 4 carbon hydrogen bonds. So there need to be an excitation so that this electron can migrate to this orbital. So in excited state of carbon, one electron from 2s orbital migrate to 2p orbital. So in excited state it will be like this. Now here the carbon can gain 4 unpaired electron with the mixing of s and p orbital giving rise to s or 3p. So total sp3 hybridization. So here in excited state, carbon mix up their atomic orbitals to form sp3 hybrid orbitals, and both have one unpaired electron. So in CH4 there occurs the overlapping of the atomic orbitals. So this is the hybrid orbitals of carbon. So with these hybrid orbitals of carbon, the 1s orbital electron of hydrogen overlap. So these are the electrons from 1s orbital of hydrogen to give CH4 molecule. So the structure of CH4 will be, this is the carbon, and these are the 4 sp3 hybrid orbital. These all are sp3 hybrid orbital of carbon. Now these 4 sp3 hybrid orbitals undergoes overlap with 4 1s atomic orbital of hydrogen. So this is 1s orbital of hydrogen. Similarly here this is 1s orbital of hydrogen. This is also 1s orbital of hydrogen, and this is also 1s orbital of hydrogen. And there are 2 electrons, one from sp3 hybrid orbital of carbon and another one from 1s orbital of hydrogen. Similarly here, and this particular orientation of the hybrid orbital of carbon is called tetrahedral arrangement, with spatial distance between two hybrid orbitals is 109 degree 28 minutes. So this is the hybridization of methane sp2. Now we can see another sp2 hybridization. How sp2 hybridization formed? For this, take an example of a covalent molecule with sp2 hybridization, and that is BCl3, boron trichloride, in which the central atom is boron with valence electron. From this table you can see that central atom boron has valence electron 3. So valence electron 3 with electronic configuration 1s2, 2s2, 2p1. So this is the valence cell with this. Now the excited state, the ground state electronic configuration of boron is, and this here we show only the valence shell because the only valence shell take part in bond formation. So this is 2s and 1 electron in 2p. Now in excited state, boron removes its 1 electron from 2s to 2p orbital. So there will be 1 electron in the excited state. So there occurs a mixing of 1s and 2p orbital, and it will give you the sp2 hybridization. Because here 1s and 2 atomic orbital p are involved in the hybridization. So this is sp2 hybridization. And now in the molecule of BCl3, the 1 electron of chlorine overlap with boron atomic orbital to give you the sp2 hybridization. That is, these are the electrons of sp2 from, these are the electrons from sp2 hybrid orbital of boron, and these are the electrons from each chlorine atom to give you the sp2 hybridization with a geometry of trigonal planar. So here the geometry of boron will be this. Here a chlorine, this is another one chlorine, this is another one chlorine, and this spatial arrangement is called trigonal planar. जैसे कि हम प्रीवियस क्लास में आप लोगों को बताए थे कि sp2 हाइब्रिडाइजेशन के लिए स्पेशल अरेंजमेंट ट्राइगोनल प्लेनर होता है. सो दिस इज ए ट्राइगोनल प्लेनर ज्योमेट्री with the spatial distance between two bonds is 101 degree. This is also 101 degree 28 minutes. This is also 101 degree 28 minutes. So this is the sp2 hybridization. Clear? Now we can take another example of sp3d hybridization. Now we can take another example of sp3d hybridization. For this, take an example of the molecule having sp3 hybridization is PCl5, phosphorus pentachloride, in which the central atom phosphorus has sp3d hybridization. So here central atom is phosphorus. And from the periodic table we can see that phosphorus is the element of group 15 having valence electron high. So number of valence electron equal to high, and the electronic configuration for the valence shell will be, neon 10 3s2 3p3. Clear? So this is the valence shell having 2s electrons and 3p electrons, having 2s electrons and 3p electrons. So total 5 valence electron is present in phosphorus. Now listen, being phosphorus is an element of third period, it will have a vacant d orbital. So this is the 3s orbital, this is 3p orbital, and this one is 3d orbital of phosphorus. Now ground state configuration for phosphorus is, now the ground state electronic configuration for phosphorus atom is like that. So you can see that in that case phosphorus have only ability to make 1, 2, 3 covalent bond with 3 chlorine atom, but in PCl5 there is total 5 PCl covalent bonds. So in the excited state phosphorus promote its 1 3s electron into the higher 3d orbital to make 5 unpaired electron. So this is the 3d. So one of this electron will be migrate to this orbital, so it will be like that. So now 1s, 3p and 1d orbitals are involved in the hybridization, so that will give you the sp3d. So this is the sp3d hybridization, because here 1 is 3p, 1d orbital involved. Now what will be the structure for PCl5? For PCl5 it is 3s, it is 3p. Now this is 3d. तो अब 1 2 3 4 5, these are the 5 unpaired electrons from each sp3d hybrid orbital of phosphorus. Now with this unpaired electron, one electron from each chlorine overlapped to form PCl5 molecule with 5 PCl bonding, and these are the electrons from each chlorine atom. So this is the molecule of PCl5 hybridization. Now let us take the geometry of PCl5. So here this is phosphorus central atom. Now one P is here, another chlorine is here, another chlorine is here. So these 3 chlorine atom surrounding phosphorus is in a plane, that is trigonal planar. But there are more 2 PCl bonds. Between these 2 PCl bonds, one is above the plane, that is from outside the board, and another PCl bond is from inside the board. But it is difficult to show 3-dimensional in board, so we can make this. That means this PCl bond is above the board, like this way, and this PCl bond is inside the board, that is from this to this. So this is a trigonal. This orientation is called trigonal bipyramidal. This orientation is called trigonal bipyramidal. Where there is total 3 bond angles. One is this one. This fluorine and this fluorine are called axial position, and these 3 positions are called equatorial position. So here this and this position are called axial position. So there is 2 axial PCl bond, and these positions are called equatorial position. So there are 3 equatorial fluorine atoms. Now this bond, that is axial fluorine, central atom phosphorus, and equatorial fluorine, this bond is 90 degree. Axial fluorine, central phosphorus atom, and another axial fluorine, this bond is 180 degree. And equatorial fluorine, phosphorus, equatorial fluorine, that means this bond is 120 degree. So there are total 3 bonds, that is axial bond is 180 degree, axial equatorial bond is 90 degree, and equatorial phosphorus equatorial bond is 120 degree. So this is the special arrangement for sp3 dehybridization. Now take another example of sp3d2 hybridization. To establish how sp3d2 hybridization takes place, we can take a proper example with having sp3d2 hybridization is SA6 sulfur hexafluoride, where the central atom sulfur is sp3d2 hybridized. Now here central atom equal to sulfur, valence electrons equal to 6. From this table you can see that sulfur is the group 16 element, so have valence electron 6. Now electronic configuration will be neon 10 3s2 3p4 with 3d0. क्लियर ना? ये अब ये हो गया. This is the 3s orbital of neon. Sorry, this is the 3s orbital of sulfur. These are the 3p orbital electrons, and there is again 3p. Now this is the sulfur ground state electronic configuration. Now in sulfur excited state. So you can see that in such situation sulfur has only the ability to form 2 covalent bonds with fluorine atom, but actually in SF6 there is total 6 sulfur fluorine bonds. So to accommodate all the fluorine atoms surrounding sulfur, sulfur has to promote this 3p electron into higher 3d, and also this 3s electron into higher 3d. That is, this will be migrated to this, and this will also to this or so. In excited state So in excited state it will 1, 2, 3, 4, 5, 6 unpaired electrons with the mixing of 6 atomic orbital to give sp3d2 hybridization. Clear? अब क्या होगा? With each sp3d2 hybrid orbital of sulfur, one electron from 2p orbital of chlorine overlap to form SF6 molecule. That is, in SF6 there will be A3s, A3p, A3d. तो यह हो जाएगा each electrons. These are the bonded electrons from sulfur and these are from each fluorine atom. This is the so. Now, what will be the special arrangement of these 6 sp3d2 hybrid orbital? So here for such an hybridization, the special arrangement is octahedral, in which the central atom surrounded by 4 atoms in a plane. That is, these 4 atoms are in a plane, that is a square plane, and 1 atom is above the plane and 1 atom is below the plane. So these 4 atoms are in a square plane. 1 atom is from above the plane and another atom is from below the plane. This is called axial position and this is called equatorial position. So you can see that there is total 1, 2, 3, 4 equatorial fluorine atom and 2 axial fluorine atom. There will also be 3 types of bond. One is axial sulfur equatorial. This bond is 90 degree. Equatorial sulfur equatorial. This bond will also be 90 degree. And this bond, axial bond is 180 degree. Clear? So there will also be 3 types of bond. One is axial equatorial bond, that is equal to 90 degree. One is equatorial bond, that is equal to 90 degree, and one is axial bond, that is chlorine sulfur fluorine, that is equal to 180 degree. So this is the special arrangement for sp3d2 hybridization with octahedral geometry. So students, देखिए कि we can determine the state of hybridization of central atom by this way is very much time consuming and lengthy process. So how can we determine the state of hybridization of the central atom quickly or mechanically? Now for that reason, to determine the hybridization of a central atom in a molecule mechanically, there is a formula. So let us discuss how can we determine state of hybridization. Firstly, in a mechanical way, by skipping these all steps. So देखिए students, to determine the state of hybridization of the central atom in a molecule, you have to first calculate H. What is H? Now H equal to total number of hybrid orbitals. The H क्या है? H is the total number of hybrid orbitals. That is equal to bond pairs, but only sigma bond pairs. Because pi bonds does not involved in the hybridization. or does not alter the state of hybridization. So pi bonds are not considered here. So here total number of hybrid orbital equal to bond pair, that is sigma bond pair plus of lone pairs. Clear? Lone pair or lone pairs, more than one भी हो सकते हैं. So first we have to calculate H. What is the value of H? जहाँ H क्या होता है? H है total number of hybrid orbital, total hybrid orbital की number, and that will include total bond pairs, that is only sigma bond pairs, and total number of lone pairs. So there is a formula to calculate H is H equal to half in total number of valence electrons or electron in central atom. Clear? So H equal to total number of valence electron in central atom plus number of monovalent atom. Monovalent atom. Monovalent atom means the atom which has valency 1. If valency is 1, then it is monovalent. If valency is 2, then it is called divalent. If valency is 3 for a atom, then it is called trivalent. But during the determination of H, we have to only consider total number of monovalent atom is attached with the central atom. Divalent, trivalent or higher valent elements are negligible here. Plus minus charge of cation, minus charge of cation if the species have a positive charge, then that will be minus, or plus charge of M. This is the simple formula for the calculation of total number of hybrid orbital. तो क्या हो गया? इस फॉर्मूला में क्या क्या है? टोटल नंबर ऑफ वैलेंस इलेक्ट्रॉन जानना है, नंबर ऑफ मोनोवैलेंट एटम कितना है वो जानना है, चार्ज अगर द स्पीशीज हैज आइदर पॉजिटिव चार्ज और नेगेटिव चार्ज, देन द पॉजिटिव चार्ज दैट इज कैटायनिक चार्ज विल बी माइनस और एनायनिक चार्ज विल बी एडेड. सो लेट अस टेक एन एग्जांपल. चलिए तो हम लोग जो CH4 की हाइब्रिडाइजेशन कुछ दूर पहले निकाले थे, तो अब ट्राई टू डिटरमाइन व्हाट इज द हाइब्रिडाइजेशन ऑफ CH4 बाय दिस वे. तो हियर द सेंट्रल एटम इज, सो हियर द सेंट्रल एटम इक्वल टू कार्बन. तो अब फ्रॉम दिस टेबल you can determine the valence electron of carbon is 4, so H equal to half. Valence electron of central atom is 4, so 4 plus कार्बन के साथ यहाँ 4 हाइड्रोजन एटम है. हाइड्रोजन की वैलेंसी 1 है, so हाइड्रोजन इज ए मोनोवैलेंट एटम. दैट मीन्स सेंट्रल एटम के साथ 4 मोनोवैलेंट एटम भी है, so plus 4. There is no positive or negative charge, so they are negative, so that will be equal to 4. So हम discussed in the previous class if H is 4, that is total number of orbital, total number of hybrid orbitals will also be equal to total number of atomic orbital, and we already discussed that if total number of atomic orbital is 4, then the hybridization will be sp3. So from this we can easily determine the hybridization of CH4, and that is sp3. Now number of bond pair. Now we can calculate number of bond pairs. Number of bond pairs equal to number of bonded atoms. Bonded atoms. तो नंबर ऑफ बॉन्ड पेयर निकालने के लिए इट इज ए वेरी सिंपल टेक्निक, दैट इज नंबर ऑफ बॉन्ड पेयर ऑलवेज बी इक्वल टू नंबर ऑफ बॉन्डेड एटम्स. दैट मीन्स नंबर ऑफ एटम्स present with the central atom. So here number of atoms present with the central atom carbon is 4, so here bond pairs equal to 4 and number of lone pairs equal to हो जाएगा H minus bond pairs, number of bond pairs. So here lone pair equal to that of 4 minus 4, that is equal to 0. So from this formula we can calculate state of hybridization of the central atom, number of bond pairs surrounding central atom and number of lone pairs surrounding central atom. Now take another example like NH3. So in NH3 the central atom is nitrogen. From this table you can say that nitrogen has valence electron 5. So H equal to half 5 plus central atom के साथ 3 monovalent atom hydrogen attached है, so 3, that is equal to 8 by 2 equal to 4. So hybridization for NH3 will also be sp3. Clear? Here bond pair central atom के साथ 3 atoms है bonded, so bond pair will be 3 and lone pair will be total H minus 4, that is H equal to 4 minus bond pair of electron 3 equal to 1. That will for NH3. Clear? अब चलिए और एग्जांपल लेते हैं। NH3 हो गया। अब हम लोग देखते हैं HCOF2 xenon oxychloride की हाइब्रिडाइजेशन। तो यह सेंट्रल एटम इज xenon, क्योंकि हम प्रीवियस क्लास में डिस्कस किए थे कि the atom with larger size and lowest number will be the central atom. So here xenon is only one with larger size than oxygen, so xenon is the central atom. So here central atom is xenon. Xenon being an inert gas, it has already 8 electrons in their valence shell. So total number of valence electrons in xenon will be 8 plus oxygen is a divalent atom, so cannot be considered in this formula, but fluorine is monovalent atom. So in this compound number of monovalent atom is 2, so 8 plus 2, that will equal to 5. So hybridization will be sp3d. Clear? Now bond pairs, तो central atom xenon की surrounding में total 1 2 3 bonded atoms है, so bond pair will be 3 and lone pair will be 5 minus 3, that will equal to 2. Clear? तो ऐसे कोई भी compounds की bond pair, lone pair and hybridization निकाल सकते हैं ना। Another example, let us take H3O plus hydronium ion. So here central atom is oxygen. Central atom oxygen. Central atom oxygen. Central atom में valence electron है 6, so 6 plus number of monovalent atom 3. Next, this is a cation with one unique positive charge, and in the formula the charge of cation is to be minus 2. So minus charge of cation 1, that will equal to 4. So hybridization will be sp3. Clear? Here minus 1 इसलिए आया क्योंकि H3O plus is a cation with one unique positive charge, and in the formula it is given that minus charge of cation, so minus 1. Here central atom के साथ 3 हाइड्रोजन एटम है bonded, so bond pair हो जाएगा 3, lone pair हो जाएगा 4 minus 3, that is equal to 1. Clear? So H3O plus हो गया ना। Another example, SO4 minus, that is sulfate ion. What will be the hybridization of the central atom sulfur in SO4 minus in the sulfate ion? So let us try. So here central atom is sulfur is total number of hybrid orbitals 6 plus oxygen divalent atom, so cannot be considered. But the species has 2 unit negative charge, and the formula says that charge of anion have to be plus. So there will be plus 2. That will give you the 4. H equal to half. Clear? In the formula, H will be half of this. Clear? So 4 हो गया. Bond pair हो जाएगा 4 bonded atom है, so 4 bonded atom है central atom के साथ, and lone pair will be 0. So hope you all understand how to calculate or how to determine the state of hybridization from this formula. This is a very easiest way to determine the state of hybridization, number of lone pairs and number of bond pairs in a covalent molecule. So this is. Now we can discuss another part or another important topic, that is VSEPR theory. Yeah. Now we can discuss another important part of this, that is VSEPR theory and geometry of the covalent group. Now geometry or shape of covalent molecules. Geometry and shape of covalent molecules, that is related to VSEPR theory. Geometry or shape of covalent molecules according to VSEPR theory. VSEPR theory का full form है valence shell electron pair repulsion theory. I repeat, valence shell electron pair repulsion theory. तो इस थ्योरी के माध्यम से कोई भी कोवैलेंट मॉलिक्यूल की ज्योमेट्री और शेप हम लोग डिटरमाइन कर पाएंगे। तो इसके लिए हम एक टेबल बना लेते हैं पहले कि ज्योमेट्री के, तो देखिए देयर इज कुछ सेलाइन फीचर्स फॉर द, देयर क्या होता है, देयर इज कुछ सेलाइन फीचर्स फॉर द VSEPR theory and that are shape of a molecule depends upon the total electron pairs. First है नंबर 1 क्या है कि shape of a molecule depends upon total electron pairs. तो कोई भी कंपाउंड की जियोमेट्री और शेप टोटल इलेक्ट्रॉन पेयर्स के ऊपर डिपेंडेंट है. दैट मीन्स हाउ मेनी नंबर ऑफ इलेक्ट्रॉन पेयर्स इंक्लूडिंग लोन पेयर एंड बॉन्ड पेयर्स you have to determine first, and you already know and I am already discussed how to determine the total number of electron pairs, lone pairs, bond pairs. So you have to first determine the shape of a molecule depends on the total number of electron pairs. So you have to first determine the total number of electron pairs in a molecule. Clear? Number 2, you have also be determined individually number of bond pairs and number of lone pairs. Second, आप लोगों को इंडिविजुअली किसी कंपाउंड के अंदर बॉन्ड पेयर्स कितने हैं, लोन पेयर्स कितने हैं, वो जानना है. क्लियर? नंबर 3 कि जैसे हम पहले इस टॉपिक को डिस्कशन कर चुके हैं ये बात कि जो बॉन्ड पेयर्स है दे आर अरेंज देमसेल्व्स इन ए स्पेस in such a way so that bond pair repulsion becomes minimum. So bond pairs are arranged themselves in such a way so that the repulsion between two bond pairs becomes minimum. Clear? And if so, BP repulsion becomes minimum. Clear? Bond pair repulsion becomes minimum. Number, if a molecule has both the bond pairs and more than one lone pairs, then there may be possible three type of repulsion. That is bond pair repulsion. If a molecule has bond pair as well as more than one lone pair, then there are three type of repulsion possible. That is bond pair के साथ bond pair के repulsion, between bond pair के साथ lone pair की repulsion, and lone pair के साथ lone pair की repulsion. These three repulsions are possible. तो among these three repulsions, सबसे तेज मोर स्ट्रॉन्गर रिपल्सन इज दैट लोन पेयर मोर देन लोन पेयर बॉन्ड पेयर मोर देन बॉन्ड पेयर. क्लियर? तो these are the salient features for VAC-PR theory. तो लास्ट में हम लोग बताए कि if a molecule have bond pair with more than one lone pair, then there may be possible repulsions are between bond pair, between a bond pair and lone pair, and between lone pair. And among these three repulsions, the most stronger repulsion is lone pair repulsion, then lone pair bond pair repulsion, then bond pair repulsion. So keeping all these four facts in mind, we can determine what will be the shape of a covalent molecule. क्लियर? तो चलिए इसके लिए हम लोग एक टेबल बना लेते हैं, जिस टेबल में से हम लोग कोई भी कंपाउंड्स की शेप क्या होगा वो जान लें. ठीक है? तो पहले हम लिखते हैं H, दैट इज हाइब्रिड ऑर्बिटल की नंबर. क्लियर? तो पहले हम क्या लिखे H बना दिया फर्स्ट. दिस इज H, where H equal to total number of hybrid, that is equal to bond pairs plus lone pairs. But mind you, the bond pairs are only sigma bond pairs. Clear? Next, hybrid डाइजेशन. उसके बाद एक कॉलम हमने बनाए हाइब्रिडाइजेशन के लिए कि हाइब्रिडाइजेशन क्या है वो बनाने के लिए. ये हो गया हाइब्रिडाइजेशन. अब देखते हैं नंबर ऑफ बॉन्ड पेयर्स. कोई भी एक मॉलिक्यूल में कितने बॉन्ड पेयर्स है वो इस कॉलम में हम लोग बताएंगे. अब लोन पेयर्स कितने हैं ये इस कॉलम में हम लोग बताएंगे कि हाउ मेनी नंबर ऑफ लोन पेयर्स. अब है टाइप. बॉन्ड पेयर और लोन पेयर के हिसाब से मॉलिक्यूल की टाइप क्या है, किस टाइप की मॉलिक्यूल है वो इस कॉलम में बताएंगे. क्लियर? नेक्स्ट है मोस्ट इंपॉर्टेंट, जिसके बारे में हम लोग ये टेबल बना रहे हैं, वो है जियोमेट्री. जियोमेट्री क्या होगी मॉलिक्यूल की. क्लियर? इस टेबल में हम लोग बताएंगे कि व्हाट विल बी द जियोमेट्री ऑफ द मॉलिक्यूल. नेक्स्ट है बॉन्ड एंगल क्या होगा. क्लियर? ये और यहाँ पर एग्जाम्पल देंगे. तो ये है कंप्लीट टेबल, जहाँ फर्स्ट है H के लिए, जो फर्स्ट यहाँ पर हम लिखते हैं H इक्वल टू टोटल नंबर ऑफ हाइब्रिड ऑर्बिटल्स या टोटल नंबर ऑफ atomic orbital involved in hybridization, and that will also be equal to total number of sigma bond pair plus lone pairs. फिर तो इसको एक लाइन खींच लेते हैं पहले. So let us H equal to 2 if there is total number of hybrid orbital, then hybridization will be sp। मान लेते हैं बॉन्ड पेयर है 2, लोन पेयर 0, टाइप हो गया AB2, AB2 where A, this A क्या है ऊपर लिख देते हैं, A इक्वल टू सेंट्रल एटम, A is the central atom, and B equal to bonded atom, क्लियर। यहाँ हम लिख दिए ये जो A है ये क्या है, A is the central atom, जैसे कि हम पहले एग्जांपल में दिखाया CH4, C is the central atom, so here in the type A is the central atom and B is the bonded atom। अब ज्योमेट्री क्या होगा, ज्योमेट्री हो जाएगा लीनियर, बॉन्ड एंगल हो जाएगा 180 डिग्री, एग्जांपल BeCl2 बेरिलियम ट्राइफ्लोराइड। दैट इज यहाँ हम दिखाते हैं ज्योमेट्री को, क्या होगा, ये है बेरिलियम एक Cl यहाँ, नॉट फॉर BeCl2, हम लोग AB टाइप के लिए दिखाते हैं, तो AB, तो सेंट्रल एटम क्या है A, तो ये हो गया A, this is B and this is B, and this angle is 180 degree and geometry is named linear, so this हो गया linear geometry। अब ये 2 clear, now A is equal to 3, if A is equal to 3 then hybridization will be sp2, मान लेते हैं कि बॉन्ड पेयर 3, लोन पेयर 0, सो टाइप हो जाएगा AB3, ज्योमेट्री हो जाएगा ट्राइगोनल प्लेनर, जिसमें बॉन्ड एंगल है 120 डिग्री, एग्जाम्पल BCl। तो चलिए इसमें ज्योमेट्री देख लेते हैं कि AB3 टाइप का ज्योमेट्री क्या होगा। तो AB3 टाइप में सेंट्रल एटम है A, one atom B is here, another atom B is here, and another atom B is, so this is the trigonal planar geometry with 3 bonded atoms and each bond angles are 109 degree, this is 120 degree, clear। अब इसमें और एक केस हो सकता है जो कि 2 1, दैट मीन्स 2 बॉन्ड पेयर 1 लोन पेयर, सो टाइप हो जाएगा AB2L, जहाँ L क्या है, L यहाँ हम लिख देते हैं कि L इक्वल टू हो गया लोन पेयर, फिर L क्या है, लोन पेयर, तो इसमें एक लोन पेयर है इसलिए AB2L। जियोमेट्री हो जाएगा बेंट या V से, क्या होता है बेंट या V से, बॉन्ड एंगल होगा लेस देन 120 डिग्री। तो चलिए इस ज्योमेट्री बेंट ज्योमेट्री को हम लोग यहाँ देख लेते हैं, यहाँ पर बेंट ज्योमेट्री को देख लेते हैं, क्या होगा, एक सेंट्रल एटम, उसके साथ एक एटम है B और एक बॉन्डेड एटम है B, और यहाँ पर एक लोन पेयर है, सो दिस इज कॉल्ड बेंट ज्योमेट्री एंड दिस एंगल is called BAB bond angle which will be less than 120 degree। तो ये हो गया 3 के AB, ये हो गया 3 के, जैसे कि इसके एग्जांपल हो जाएगा SO2, ठीक है। अब आता है 4 हो गया, तो एक हाइब्रिडाइजेशन है sp3 with 4 bond pair 0 lone pair, टाइप हो गया AB4, ज्योमेट्री हो जाएगा टेट्राहेड्रल with bond angle 109 डिग्री 28 डिग्री। तो यहाँ देख लेते हैं ज्योमेट्री क्या होगा, सो ज्योमेट्री होगा सेंट्रल एटम A, उसके साथ यहाँ 1 bonded atom, this is 1 bonded atom, this is 1 and 1 bonded atom is above the plane, so we can write another B in a dot, this is another B, and here all the bond angles are 109 degree 28. This geometry is called tetrahedral ज्योमेट्री। क्लियर? अब देखते हैं अनदर केस 3 1 मींस 3 बॉन्ड पेयर 1 लोन पेयर, तो टाइप हो जाएगा AB 3L, ज्योमेट्री हो जाएगा पिरामिडल। पिरामिडल बॉन्ड एंगल होगा लेस देन 190 डिग्री 28 मिनट। जैसे कि एग्जांपल है इसके लिए CH4, इसके लिए NH3। सो यू नोटिस here is 3 bond pair 1 lone pair, so among the 4 bond pair 1 will be removed, so this bond pair will be removed and there is a lone pair. Now this bond angle will be less than 190 degree 28 minutes and this geometry is called pyramidal geometry. अब another case 2 bond pair 2 lone pair, तो टाइप हो जाएगा AB2 AB2, दैट मींस 2 बॉन्ड पेयर सेंट्रल एटम के साथ 2 बॉन्ड पेयर है 2 बॉन्ड पेयर है, तो इसमें ज्योमेट्री हो जाएगा बेंट और V शेप। क्लियर? सिमिलरली बॉन्ड एंगल हो जाएगा लेस देन 190 डिग्री 28 मिनट, एग्जांपल H2O। अब देखिए इसमें 3 बॉन्ड पेयर्स, अब और एक लोन पेयर हो जाएगा तो क्या होगा, और एक बॉन्ड रिमूव हो जाएगा, दैट मींस ज्योमेट्री हो जाएगा A 1 bond AB, इधर 1 AB bond and there is 2 lone pair, this is 1 lone pair and this is another lone pair, this is called V shape geometry। V, this is V, ये V shape geometry हो गया। क्लियर? और बेंट, तो ये हो गया sp3 के लिए, और 4 के लिए और एक हाइब्रिडाइजेशन पॉसिबल है, ये हो गया sp3 हाइब्रिडाइजेशन के लिए। अब 4 बॉन्ड पेयर और लोन पेयर, तो 4 H का वैल्यू 4 होने से और एक हाइब्रिडाइजेशन पॉसिबल है, दैट इज DsP2, जहां बॉन्ड पेयर है 4, लोन पेयर है 0, टाइप AB4, दैट इज कॉल्ड स्क्वायर प्लेनर, PLA, that is called square planar। एग्जाम्पल बॉन्ड एंगल हो जाएगा 90 डिग्री, एग्जाम्पल PtCl4 2 बेसिकली with 4 electron pairs DsP2 hybridization is possible for transition or D block elements। For main representative element S or P block this is not possible, and for the chemistry of transition element discussed in 12th class, but now you remind that for hybridization 4, for total number of orbital 4, 2 hybridizations are possible, एक sp3 एक dsp2, तो ये हो गया 4 के लिए। क्लियर? तो ये हो गया टोटल नंबर 4। क्लियर? अब है ये हो गया 4। नाउ वी कैन सी 5, तो देयर इज नो स्पेस इन द बोर्ड, सो हम ऊपर लिखते हैं, तो अब है 5, तो 5 को यहाँ लिख देते हैं 5, तो 5 है तो हाइब्रिडाइजेशन हो जाएगा sp3d। मान लेते हैं बॉन्ड पेयर 5 लोन पेयर 0, टाइप हो जाएगा AB5। ठीक है, ज्योमेट्री हो जाएगा ट्राइगोनल बाइपिरामिडल, ज्योमेट्री हो गया ट्राइगोनल बाइपिरामिडल। ठीक, जहां पर हम दिखाए ऑलरेडी शोन इन ट्राइगोनल बाइपिरामिडल देयर इज 3 बॉन्ड एंगल, one is 180 degree, that is axial bond angle, one is 90 degree, that is axial equatorial bond angle, and one is 120 degree, that is equatorial bond angle। clear? Example PCl5। ट्राइगोनल बाइपिरामिडल ज्योमेट्री क्या होगा, यहाँ पर हम लोग देखते हैं TBP ज्योमेट्री को, तो AB5, तो यहाँ पर सेंट्रल एटम है A, 5 बॉन्ड पेयर्स 1 2 3। ये हो गया 3 इन ए प्लेन, one is above the plane B, another one is below the plane B. So ये हो गया TBP और trigonal bipyramidal geometry with 5 bond pairs, no lone pairs. Now इसी टेबल को यहाँ कंटिन्यू हो जाता है, ठीक है। 5 with sp3b हाइब्रिडाइजेशन, अब है 4 बॉन्ड पेयर 1 लोन पेयर, तो टाइप हो जाएगा ab4l ab4l। इन दैट केस ज्योमेट्री विल बी seesaw or it is also called irregular tetrahedral। Bond angle will be less than 190 degree, 28 degree, less than 100, less than 120 degree। तो आप देख रहे हैं seesaw geometry क्या है, देखते हैं। तो यहाँ पर in the previous case, in case of AB5, there have 5 bond pairs. Now between these 5 bond pair, 1 lone pair and 4 bond pair. So remove 1 bond pair, whether in that case there is a lone pair. So here now 1, 2, 3, 4, total 5 bond pairs and 1 lone pair, and this geometry is called seesaw geometry। Clear? तो ये हो गया। अब another case for this 3 bond pair 2 lone pair, 3 bond pair 2 lone pair, तो टाइप हो जाएगा AB3L2, AB3L2। तो इन दैट केस ज्योमेट्री है टी शेप, ज्योमेट्री है टी शेप। तो यहाँ हम लोग देखते हैं टी शेप ज्योमेट्री। तो इसमें क्या है, 2 बॉन्ड पेयर्स आर रिमूव्ड। सो वी हैव रिमूव्ड 2 बॉन्ड पेयर। यहाँ एक बॉन्ड पेयर है, सो 1, 2, 3 bond pair and 2 lone pair। This one, these geometries look like T, so it is called T set। तो यहाँ जो है 5 bond pair, टोटल नंबर ऑफ ऑर्बिटल्स 5 हो गया। तो इसमें 3D हाइब्रिडाइजेशन के लिए एक टाइप हम देखिए 4 बॉन्ड पेयर 1 लोन पेयर, तो हो गया सीसॉ। अब 3 बॉन्ड पेयर 2 लोन पेयर हो गया, तो हो जाएगा टी शेप, एंड 2 बॉन्ड पेयर 3 लोन पेयर दैट इज AB2L3 टाइप ज्योमेट्री है लीनियर, जो कि ये है लीनियर, जिसमें सेंट्रल एटम एक के साथ 2 बॉन्डेड एटम है एंड 3 लोन पेयर्स। अब है 6 है, तो हाइब्रिडाइजेशन होगा इसमें 3D2, एंड इन दैट केस इफ देयर इज 6 बॉन्ड पेयर्स 0 lone pair type AB6 with octahedral geometry, this is the octahedral geometry, and if there is 5 bond pairs with 1 lone pair that is type AB5L, then the geometry is called irregular octahedral। Clear? In that case the geometry will be irregular octahedral, bond angle less than this। And another one and last bond pair and lone pair equal to 7 with sp3d3 hybridization। In that case 7 bond pair 0 lone pair type AB7 will have the pentagonal bipyramidal geometry, that will be A B B B B B। ये 5 एक प्लेन में है, 1 atom is above the plane, 1 is below the plane। This is called pentagonal bipyramidal geometry। So इस टेबल को आप लोग अच्छे से तैयार कीजिए। The lecture for today ends here, so stay home, stay safe, thank you।